Welcome to The Explainer. Today, we're diving straight into the blueprint for taking your electronic health record system from a clunky legacy headache and transforming it into a truly intelligent AI native platform. We're going to look at what it literally takes to design a system where artificial intelligence isn't just tacked on as an afterthought, but is the actual beating heart of your clinical workflows.
Let's kick things off with a pretty stark reality. Physician burnout. It recently peaked at a massive 62.8%. And honestly, a huge driver of that burnout is the massive cognitive load and the endless administrative burden of traditional, rigid EHR systems. I mean, clinicians are spending way more time managing software than actually managing patient care, right? And that's exactly what we need to fix.
So, the solution here isn't just bolting on some AI assisted features onto your legacy platforms. Think about it. When you just bolt AI on, it acts like this completely separate service. It requires external data extraction, it's totally reactive, and honestly, it just adds to that cognitive load we just talked about. Instead, we have to build an AI native architecture. This means the intelligence is literally baked right into the system's DNA from day one. It's built in, it's continuous, and it relies on automated event triggers to proactively support the clinician. Our blueprint today is kind of like a four-layer cake. We are going to start with strategic planning, move right up into modular architecture, dive into the 5 clinical AI patterns, and then cap the whole thing off with the ultimate requirement for any clinical AI: trust and auditability. All right, let's jump right into layer 1, strategic planning. This is the absolute foundation of AI native EHRs. Look, strategic planning is really all about balancing competing needs, and you have got to do this before a single algorithm ever touches your workflow. Clinicians want speed, right? But operations teams, they need compliance. So you have to define those core user personas super early on. You also need to identify broad, system-level use cases, like, say, population-wide risk scoring, instead of just cherry-picking isolated standalone features. And at this stage, you've got to make the big call. Are you going to build a custom EHR or extend your existing one? You have to align with clinical and regulatory realities right out of the gate. Moving right along to layer 2, modular architecture. This is the structural framing you need for a truly canonical AI architecture. To actually make this work in the real world, you need this constant circular flow between 4 vital subsystems. These are the engines required for predictive analytics and full-scale AI lifecycle management. You just cannot run an AI-native system on some old monolithic database. You need a highly modular approach that can handle the constant heavy flow of data, model training and deployment, and do it all safely. I like to think of this whole setup as a highly coordinated factory. First, you have the inference framework. That's the brain, generating real-time insights and prediction metadata on the fly. Next up is the model management subsystem, which registers, serves, and continuously monitors your machine learning models for any drift or skew. Then you've got the feature repository handling your version-controlled data pipelines. And finally, the dev toolkit, which is what empowers your data scientists with the exact tools they need for cohort construction and model design. Now, underpinning this entire structure are FHIR-based data pipelines. And guys, this is absolutely crucial because FHIR standards standardize event-driven data exchange. What does that actually mean for you? Well, it means when a lab result updates, the system doesn't just sit around waiting for a nightly batch job to run. Boom, the event instantly triggers the AI to provide real-time, low-latency intelligence straight to the clinician. It's an absolute game changer. Okay, let's step into layer 3, the 5 clinical AI patterns. Think of these as the functional rooms of our house. Now, these aren't just cool, flashy features. These 5 distinct patterns are literally the most powerful ways to eliminate clinical friction. But they only work like this when the AI is natively built into the system, not just slapped on at the end. So let's break down how each one of these practically tackles those everyday workflow bottlenecks. First up is ambient clinical documentation. This uses audio capture and large language models to essentially listen in on the natural conversation between a doctor and a patient. And as they're just chatting normally, the AI automatically drafts structured clinical notes, things like SOAP notes or history and physicals, in real time. It literally allows the doctor to actually look at the patient eye to eye instead of just staring at a computer screen typing away. And the impact of this? It's completely staggering. Implementing this exact ambient architecture in a functional medicine platform resulted in a massive 70% reduction in documentation time. Just imagine giving clinicians back that much of their day to actually focus on patient care. It's huge. Next, we have clinical decision support, or CDS. Because this whole architecture is event-driven, CDS is able to proactively flag issues right there in the workflow. For instance, by integrating an AI-native CDS tool, one system actually reduced missed pre-op labs from 15% all the way down to just 2%. It catches the error before the patient even gets close to the operating room.
Pattern number 3 is predictive analytics. Now, unlike CDS, which happens right there at the point of care, predictive analytics is always operating quietly in the background. It's continuously calculating proactive risk scores at both the patient and the broader population levels. So it's identifying things like readmission risks, patient deterioration, or those hidden care gaps well before they ever turn into critical emergencies. Fourth on our list is natural language processing, or NLP. You can think of this as the ultimate translator. It unlocks all that messy, unstructured data trapped in free text notes, scanned discharge summaries, or random PDFs. It automatically extracts the structured data, like ICD-10 codes or medication lists, and then maps them right back to your structured FHIR data model. And to round out the 5, we have intelligent workflow automation. This handles all the complex, behind-the-scenes operational logistics. By using an AI scheduling engine to intelligently match patients with the perfect provider based on things like visit type, age, and location, one platform actually reduced scheduling friction by 45%. It just makes the entire business side of healthcare run so much smoother, not just the clinical side.
All right, bringing us to our final layer, layer 4, trust and auditability. This is our security roof, where we have to tackle the massive elephant in the room, clinical trust and system safety.
Look, regulatory frameworks like the EU AI Act and FDA guidelines are super clear. We absolutely cannot simply trust AI outputs blindly in a healthcare setting. I mean, when human health is on the line, an AI black box is just completely unacceptable. We need rigorous transparency, we need risk management, and we need total accountability.
So how do we actually solve this black box problem? Well, we do it with an auditable framework known as retrieval augmented generation. In this setup, every single claim the AI makes is sourced verified against curated, high-quality medical literature before it is ever presented to the clinician. No hallucinations, just verified facts.
Here's how that pipeline actually flows. First, it retrieves verified evidence from a totally trusted knowledge base. From there, the large language model acts as a reasoning engine over that specific verified data, and literally only that data. It then synthesizes an answer and provides exact inline citations. And finally, it securely audits and logs that entire process in the background.
And by committing every single one of those actions to an immutable log, we create this bulletproof, tamper-evident paper trail. We have a fully reconstructible path from the source material right down to the final decision. It captures the query, it captures the hashed patient data to protect privacy, the source IDs, and literally every inference step the AI took, which, as you know, is absolutely necessary for strict regulatory accountability.
The absolute most crucial takeaway here is that this transparent architecture always keeps the clinician in the loop. The AI is the ultimate assistant, right? It suggests, it retrieves, it drafts, but the clinician remains the ultimate boss. They review the citations and they verify the AI suggestions before anything ever becomes part of the official medical record.
As we wrap up this explainer, I want to leave you with a thought to really chew on for your own clinical systems. Are you just buying isolated tools that add more alerts to a doctor's already overflowing plate? Or are you investing in a true architecture that actually does the work for them? Thanks so much for joining me today, and hey, it's time to start laying the foundation for a truly AI-native future.